Hello and welcome to Rahman Digital Production. This is lecture number 6 of topic number 2, which is related to the speed, velocity, and acceleration. In the last lecture, we talked about the speed and different types of speed. You know that speed is a scalar quantity. It doesn't have any direction. While today we are going to talk about the velocity. Velocity is a vector quantity. It means that it is having direction as well as magnitude for its proper representation. What is velocity? Let us define first velocity. Uh, Rate of change of displacement, rate of change of displacement is called velocity, is called velocity. Or we can say there is another definition of velocity. Speed in particular direction is called velocity. Direction is called velocity. Yes, this is also the perfect definition of velocity. Velocity is represented by small v, and it is a vector quantity. It means that velocity must have a direction. The velocity must have a direction. Okay, there are different types of velocity. We will discuss that after the displacement time graph. Most important information can be obtained from the velocity from the displacement time graph about the motion of an object. In this case, if there is a car which is starting from point O and then it is moving in a straight line. It is moving in a straight line. Remember, in a straight line. So we will discuss the motion of this car. It is starting from point O and it is moving in a straight line. We are considering, and this is, if graphically we are representing, then this is that O, which is called origin. The motion is originated from this particular point. Is this straight line we are obtaining from plotting the graph of motion? There are different time intervals, 1, 2 second, 3 second, which is represented on x-axis, and there is y-axis as well, on which we are representing it with the displacement. So displacement are 20, 40 up to 140. Now, this type of motion in which a body covers equal distances in equal interval of time is called uniform speed. Equal interval of time equal distances in equal interval of time, then this is called uniform speed. Ladies and gentlemen, you must have to understand that what is the difference between uniform speed, yeah, uniform velocity, and a constant velocity, because these sort of questions can be seen in the CIE exam very frequently. So you must understand this B part and this A part. This is called constant velocity and this is called uniform velocity. How we will define it? If a body, yeah, if a particle, yeah, if an object covers equal distances in equal interval of time, then we are saying that the body, a particle, is moving with uniform velocity. And we will prove that how it is covering in this particular case equal distances in equal amount of time. In the second case, we are saying that what is constant velocity. If an object is moving in a straight line without changing its direction, then we are saying that it is moving with the constant velocity. A is showing the constant velocity and B is showing the uniform velocity. This is also uniform speed. The time, the displacement time graph, the gradient, I should say, the gradient of displacement time graph gives a speed, yeah, velocity at that particular instant. Remember that we are going to plot the graph of the motion of the car, which is starting from point O and it is moving towards the right. This line shows that this car is having only positive values. This is going in positive direction. No negative direction is there. I told you that gradient. What is gradient? The slope of this line will give us the velocity of the body at that particular time. We will study two different types of graph, one with a straight line and one which is not having the straight line. First we are discussing this. I told you that gradient of this line. So at this particular instant we want to find the velocity of this car. So we have to draw a horizontal line and a perpendicular line which is making an angle of 90. In this case there must be an angle of 90 as well. In mathematics course we will learn that what is actually gradient, what is negative gradient, what is positive gradient. But for the time being, because this is relating to this topic, so we are saying gradient is called rise divide by run. So how many time you are going, how many seconds you are going, Here you are going in the horizontal direction from 1 to 2. You have to subtract from this to this 1, and that will call delta because this is representing t. So delta t is equal to 2 second minus 1 second, which is equal to 1 second, and we have denoted this by 1 second here. Now in this case, because this is 40 parallel to 40 and this is parallel to 20, so delta s1, this is delta t1 and this is delta s1, and delta s1 is equal to 40 because this is 40 minus 20, and that is called change in displacement. How much change we are observing? This is 20 meter, 20 meter of displacement. So it is given delta S1 is equal to 20. Now you know that velocity is rate of change of displacement with respect to time. Rate this delta, ladies and gentlemen, representing change. We can say small change, not large change, small change in either time or displacement. So we found the displacement 20, and we also found the change in time is 1. So it means that this is 20 meter and this is 1 second. So when we calculate this 20 meter per second towards the right, so this is called as the 20. Now here it is 20. Let us find it here. So here if you see that the time change is this one, so it means that delta t2 is equal to 6 minus 3, which is equal to 3 seconds, and it is written for you in advance that 3 seconds. How we got this? I explained it. Similarly, delta s2 is equal to, because delta S2 is here 60 and here it is 120, this line. So it means that 120 minus 60 is equal to 60 meter. Now if we want to find the velocity, then 60 divided by 3, because it is 3 and this is 60. So 60 divided by 3 is equal to 20 meter per second. Again, uh, 20 is here and 20 is here. So it means that when we are getting a uniform, a straight line, then it means that it is showing uniform speed. It is uniformly increasing, not variably. But if we are studying this type of graph, then at A and at C, we are saying that the body is stationary, the body is still, the body is not moving, neither it is moving in right direction, neither it is moving in downward direction. So here we are observing different values of the velocity. At A and C, the body is stationary. At point A and C, the body is stationary. It is not moving, it is stopped. But one thing you must have to keep in mind, that in this case it is also moving in a positive direction. It is moving in a positive direction because this axis, this quadrant represents positive. Now if it is moving in this quadrant, then we will observe negative. But for the time being, we are taking a simple case and we are saying that this body is moving in a positive direction. Okay, here you have to see that if the triangle is larger, the velocity is high. If the triangle of the gradient line is smaller, the velocity is smaller. Here it is at A, this is greater than this and smaller than this. The velocity is smaller than this. At point B, the displacement increases uniformly. At point B, because this line is straight, this line, so it means that here at point B it is increasing uniformly. At C it is stationary, and right after the C it is moving in opposite direction. It means that the velocity is decreasing. Remember that delta S1 divided by delta T1 is greater than delta, this is T, same interval of time, and delta S2 divided by T. I told you few moments ago that if the size of triangle is small, then it means that velocity is small, change is small. And if there is a large triangle, so it means that this is the small one and this is the large triangle, so it means delta S1 divided by delta T is greater than delta S2 divided by T for the same interval of time. This is because this T and this T, delta T must be the same for the same interval of time. In this case, it is increasing uniformly. At A, it is stationary. At B, it stops for momentarily. And then it is coming down with the reduced velocity. Here, the reduction of the velocity is greater than at this E point. This is smaller. The velocity reduced is smaller than at D. So you have to keep these points in mind while observing the time displacement time graph. Ladies and gentlemen, it is also written in the book that displacement time graph, everything which I told you, it is written in the book on page number 20. Now, one question is here in the self-assessment, that can you tell from a displacement time graph whether an object is stationary? Yes, from the displacement time graph, if a line is straight, then it means that it is stationary, as I told you at A and C. Yes, you can. The instantaneous velocity can be obtained by for a very short interval of time. This interval of time, for example, this is very small triangle. So this is called instantaneous velocity. As I told you, in case of the uh, speed, instantaneous speed, the same case is with the forward for instantaneous velocity. The velocity of a body of or of an object for a very small interval of time is called what? It is called instantaneous velocity. Then it is average velocity. As it was the case in average speed, then it is average velocity. Average velocity is the total displacements divided by the total time is called average velocity. A t is equal to 6, for example, in this case. If I want that this is having 60 at 6 seconds, the displacement is 60, then it means 60 divided by 6 is equal to 10. That is instantaneous velocity. Instantaneous means from 5. If you are taking it like this and you are saying 100 for 5, if you are taking it 100, so 100 divided by 5 is equal to 20, means instantaneous velocity. For 6, if you are taking it is at 120, so 120 divided by 6, again it is 20. For 3, if you are taking it is 60, so 60 divided by 3 is also equal to 20. So it means that it is uniformly increasing. See, I am giving you another example, very important example for your concern. If this is the displacement, for example 50, there are many down and upward values, and the time is changing 1, 2, 3, 4 and 5. At 1, the speed, the displacement is 50. 50 divided by 1 means 50. Okay, again at interval 2 it is also not 50 is not changing. From 3, time is changing, but the displacements are not changing. It is 50 here, it is 50 at 1, at 2 and 50. It means that it is constant velocity. There is a constant 50, 50, 50, 50. So it means constant. And if it is like this, ladies and gentlemen, that it is like this 0, 0, 0, 0, 0, 0, yani at 1 also 0, at 2 also 0 displacement, at 3 also 0, at 4 second also 0 displacement, and so on. So it means it is stationary. When it is in front of the O, so it means that it is what? It is stationary. And now When there is a displacement, so it is constant. In this case it is constant, in this case it is stationary, because on the x-axis is the displacement is there, then it means it is stationary, it is not changing, no displacement is there, so it means that it is zero. So you saw that from graph we are getting very important pieces of information. You saw that we can see that whether it is moving uniformly or whether it is moving with constant speed. So here instantaneous speed and velocity also defined. For example, if I want, there is a line like this, and I want to find the speed or velocity at this particular instant, then you have to draw a line which is touching only that point, and then you have to find what you have to find the horizontal distance and the vertical, yeah, perpendicular distance. So if we want to find the velocity at this particular point A, then this is called instantaneous velocity or instantaneous speed, both the cases. If we want to find the average speed, so we can find that the average speed is also find by finding different speed at this particular instant. At this particular instant you will find the speed, and at this, and then you have to add all these velocities, divide by the number of time you found the velocities. So this, in this way we can find the average velocity and average speed as well. And instantaneous speed can be found by a particular interval of time, and I told you that as well. Here it is also in this book, it is mentioned that delta t means small change in time. Small change in time. How? What does it mean? It means that if we want to find at this particular, that how much is the change in the time, from 0 it went to 3, so change means difference. 3 minus 0 means 3. And similarly, delta S is equal to small change in displacement. Small changes in displacement. If we are taking it vertically, then it means that from for example, we took here 120, so 120 minus 60, this much change occurred. So 120 minus 60, which is equal to 60. People are confusing that this is what? This is delta. And delta means small change in physics. Delta means small change in this. Okay, so remember that velocity is represented by meter per second with direction. You must have to mention the direction. Speed is defined as meter per second with no direction. There is no need to show the direction. Meter per second means this is speed, and meter per second with direction means that this is velocity. Velocity is a vector quantity. speed is not a vector quantity. What is vector quantity? It must have a magnitude as well as direction. Those physical quantities which can be completely specified by its magnitude as well as direction, then it is called what? It is called vector quantity. So velocity is a vector quantity. For example, a body is moving. This is north and this is east, for example, and a car is moving here. So you will say that the car is moving with 50 km per hour northeast. So it means that we are showing the direction. So it means that it is a vector quantity. But if you are only saying that this car is moving with 50 km per hour, then it means we are not showing any direction. So it is a scalar quantity. So from the unit you can see that whether a quantity is vector or scalar. Let me summarize it. For example, if somebody is asking you a car is moving with 50 km per hour, is it speed or it is velocity? Because both are having the same unit, that is meter per second or kilometer per hour. So we can see that there is no mention of direction here, so it means it is speed. If there is a mention of direction, for example 50 km towards Islamabad, so it means that it is what? It is then velocity. That was the whole story about the displacement time graph. But one thing there is a question I want to tell you. The self-assessment on page number 19. What is the difference between speed and velocity? Speed is the rate of change of distances and velocity is the rate of change of displacement. So this is the main difference. Another difference is that speed is a scalar quantity while velocity is a vector quantity. There is it, you have to tell me in the comments section that there is a difference of unit between velocity and speed. You must have to, both are having meter per second. There is another question, far very important question. Please pay attention. For an object that is moving at a constant velocity, is it necessary for it to be moving in straight line? Yes. It must move in a straight line because velocity is having magnitude as well as direction. So if it is changing either magnitude or direction, then it not remains velocity, it yields acceleration. People are saying that if it is moving in circular motion, that is called angular velocity. We are not talking about the angular velocity. At each particular instant it will change its direction. So when it is changing its direction, it is called acceleration, then rate of change of velocity. How? Velocity is having two things, magnitude, either magnitude should change or velocity should direction should change, then it is. But for the velocity to be constant, it must have to be in a specific direction. So, yes, moving in a straight line with a constant velocity, it is necessary that it should move in the straight line. Okay, that's it for today. Inshallah, in next lecture, we will discuss more concept about this chapter. Please subscribe my channel if you haven't yet subscribed. Support me so I will make more quality videos on this. Press the bell icon so that you will get an immediate notification when I upload the new video. Thank you very much. Allah Hafiz.